Hi. Now, in this tutorial, what I want to do is show you how we can construct a typical Venn diagram for a problem like this, answer a few probability questions, and at the end here I've got a special probability question, which is what we often call conditional probability. So first of all, what have we got? We've got 100 people took part in a wine tasting survey, and the following results were recorded. And I've listed what those results were. 86 like wine A, and so on. Okay? And what we're going to do is, first of all, display this information in what is called a Venn diagram. Now, a Venn diagram is basically a diagram that sorts out our information. And what you need to do is draw some kind of border, normally a rectangle, and then we put the categories that we've got here. We've got people who liked wine A, wine B, and wine C. So you draw any three shapes, okay? Normally it tends to be circles or ovals, ellipses, okay? So I'm going to do it something like this. And you have them overlapping one another. Then we label them A, B, and C. Now, we're told that 86 liked wine A, okay? Now that means that in this set round here, this is the people who liked wine A, okay? It's not this bit just in here. You can't go around writing 86 in here, because this would just represent 86 that liked just A, and they didn't like B or C. And that's not the case. 86 like wine A, that is the total of whatever number you put in here, 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 and here. Okay? So it's got to total 86. Well, we're not in a position to know what each of these individual numbers are. Similarly, it says 89 like wine B. And that means that essentially this region, this region, this region, and this region should total 89. Again, you shouldn't write 89 in here. That's 89 just like wine B. And the same argument applies when we look at 90 that liked wine C. Okay? Now, what about this 83? 83 like A and B. 83 would like A and B. Well, A and B is this region in here. Okay? I know some of these people might like C as well, but that's not the point. They certainly like A and B. So again, we've got a problem. We can't stick, say, 83 just in here, because that would be 83 just like A and B. Okay? If there was, say, a 2 in here, that would be 85 like A and B. 83 just like A and B. So we've got a bit of a problem here. We can't fill anything in for the 83. Nor can we fill anything in for the 85, because 85 like B and C, that added to that should come to 85. And similarly, 81 like A and C. A and C would be those two regions. So, where do we start? Well, we go right to the end here. 80 like all three wines. That means that value in the middle is the 80. And so often with these kind of questions, you normally find that the number that you can insert tends to be at the end rather than at the beginning. So, in this particular problem, what we need to do is just stick 80 then in the middle there. Okay, so we've now got 80 like all three wines, and what we normally do is start to work backwards up through the list. We've got 81 like A and C. Now A and C was these two regions, so clearly we've already got 80, and there'll be one here, 81 like A and C. This one here just says that one person likes A and C only, or just A and C. Now we can go to the 85. 85 like B and C. So B and C is this 80 and this region here. So we need another 5. 85. 83 like A and B. So 83 is A and B, that's these two, so it must be a 3 in here. Now we can look at, say, 90 liked wine C. So wine C is all of this, okay? We've already got 80 and 5 and 1, so that's 86. So there's got to be 4 more left to make that up to 90. 4 people here just liked C. 89 like wine B? Well, we've got so far 85 and another 3 is 88. All of this is wine B. So what have we got left to bring this up to 89? Just one more person. And finally, well, I say finally, it's not quite actually, as you'll see in a moment, but 86 like wine A. Okay, so we've got wine A here, 86, so we've already got 83 and one more, 84, so that leaves us with 2 just liking A. Now I said that was finally, but it's not necessarily, because always check that if you were to add up all these numbers, okay, does it come to 100? Well, maybe it does, maybe it doesn't. Well, I'll leave it up to you just to add all of these individual regions up, but you should find that it comes to 96. And that means that we've got 4 more people left over. And those 4 people have to go on the outside here. These will be people who do not like A, B or C. So we've got our 100. And that's why we need a border round our sets that we draw, because there could be some people or some category that is not or has nothing to do with your categories that you list in here. Alright? Okay, so that's our Venn diagram. Now we should be in a good position to answer these questions. The first one, and I've written P just short for probability. We're trying to work out the probability that we have people that like none of the 3 wines. What's the probability that we have someone that likes none of the 3 wines? Well, none of the 3 wines has to be that 4 there. Okay, so what we've got is that this equals 4 out of the 100 people. Everything, okay, comes to 100, so it's 4 out of 100. Now I know you could cancel this down to 2/50ths or 1/25th, but I must admit I'm just leaving them in this kind of state for this example. B. Probability that we have someone that likes wine A but not B. They like wine A but not B. Where's that going to be? Well, they like wine A but not B. Certainly these 2 people like wine A but not B because they're outside of the B region. But you've got to be careful here, because this one here is someone who likes wine A. Okay, they like wine C, but that's not the point. They like wine A, but they do not like wine B. So you've got a total of 2 and 1, 3 people. 3 people out of the 100 people. So that probability is going to be 3 out of 100. Part C now. The probability that a person likes any wine except wine C. They like any wine except wine C. So where's that going to be? Well, these people in here like wine C, so we're looking for people who like a wine but not wine C. So it's got to be these 2 people who like just A, these 3 people that like A and B but not C, and this one person who likes wine B but not C. So we've got a total of 2, 3 and 1. 6 in other words, out of 100. So this probability is going to be 6 out of 100. For part D, what have we got here? Probability that the person likes exactly 2 of the 3 wines. two of the three wines, exactly two of the three wines. Be careful with this word exactly, okay? You can get phrases like likes just two of the three wines. It's the same kind of question. So it's going to be this one here. This one person likes exactly just A and C, exactly two of those wines. These three people here just like A and B, and these five people here just like B and C. So what you've got is the 3, the 1 and the 5, a total of 9 people that like exactly two of the three wines. So that's going to be 9 out of 100. Now, this last question, this is an interesting one. These kind of questions quite often come towards the end of most questions on exam papers. Now we're given that a person likes wine A, find the probability that they like wine C. And this type of probability question is often called conditional probability, and we would write this normally in this way: the probability that someone likes wine C, and we write given with a vertical line, given that they like wine A. And when you're working with Venn diagrams, these kind of questions are very easy to work out. Excuse me, they're very easy to work out because we know that the person likes wine A, so we know that it's one of these people. Okay, and how many people are there in here? Well, if you add up the 2, 1, the 80 and the 3, you'll get 86 people. Well, we've got it over here anyway. 86 people like wine A. Okay, so we know that they like wine A, but of these people, what's the probability that they like wine C? Well, it's got to be just these two categories here, the 80 and the 1. They like wine C if you were to ask them. So out of 86 people, 81 of them like wine C. So the answer is simply 81 out of the 86. Alright? Now you can answer this question by using what is often referred to as the conditional probability formula. And I'll show you that if you did use this, although we tend to use this when we're doing problems with probability tree diagrams, okay? Venn diagrams, you can just see the answer straight off, or you should be able to. But if I was doing it via the formula, you should know that the probability of C given A, one event given another, is the probability that both events occur. That's the probability of C and A. We often use this notation here, an upside down U if you like, or an N type shape, okay? C intersected with A, C and A. It's the probability that both events happen divided by the probability of the given event, and that in this case would be A. And we know that the probability of both events occurring, C and A, has to be, where is it, C and A, that's these two here, okay, this overlap. It's 81 out of 100. You've got to be careful there, it's out of 100. So 81 out of 100, and that's divided by the probability of A. Probability of A, someone liking wine A, is in here, and if you add up those numbers, we know it comes to 86. So it'd be 86 out of 100. And if you work this out, you will find you get 81 out of 86. So you can answer the problem like this, still arrive obviously at the same answer, but it's so visual from a Venn diagram rather than having to do it this way. Okay, well I hope that's given you some idea of how to answer questions like this. And that brings us now to the end of this particular tutorial.